صباح الخير جميعا. السلام عليكم ورحمة الله وبركاته، وإن شاء الله ربنا يحميكم ويحفظكم أجمعين ويحمي جميع البشر يا رب. اليوم موضوع محاضرتنا الأورال ميكوزا 1. طبعا المواضيع في المحاضرة تشمل definition and components of oral mucosa, epithelium, lamina propria, submucosa, regional variations including the lip, the cheek, the gingiva, alveolar mucosa, palate, tongue and floor of the mouth, and some clinical considerations. The oral mucosa, by definition, represents the lining of the oral cavity. It consists of oral epithelium and underlying connective tissue, called lamina propria, and the basement membrane in between. Similar to the skin has epidermis, which is epithelium, and a dense connective tissue underneath called the dermis. Here in the oral cavity, we don't call it dermis, we call it lamina propria. And the epithelium, we don't call it epidermis, we call it oral epithelium. The submucosa, before that, wherever we have epithelium and there is an underlying connective tissue, we should have a basement membrane separating these two layers. The submucosa is the third layer that is sometimes present between the lamina propria and the underlying bone or muscle. So that means in some regions in the oral cavity we have submucosa. Other regions we don't have submucosa. In cases where we do not have submucosa, the lamina propria is directly attached to the underlying supporting tissue, which could be a bone or muscle, depending on the region. By the way, the submucosa is similar to the hypodermis in the skin, which is underneath the dermis. Functions of the oral mucosa. It has a number of functions. These include mechanical protection against compressive and shearing forces, barrier against microorganisms and toxins, humoral and cell-mediated immunological defense. Minor glands, which are usually present in the submucosa, when the submucosa is present, provide lubrication, buffering, and antibody secretion. Also, the submucosa have a role as input for touch, proprioception, pain, and taste provided by its rich innervation. Here we see the components of the oral mucosa. Oral mucosa, as we said before, by definition, oral mucosa has two layers, epithelium and underlying lamina propria. The third layer, submucosa, might be present, might be absent. Then we have here either underlying muscle or bone. In this figure we have underlying bone. bone is covered with periosteum, which is dense connective tissue. Submucosa is a loose connective tissue with lots of fat cells. It has large veins, large nerves, and large arteries. Oral epithelium is classified as stratified squamous epithelium. Means it has multiple layers of epithelial cells, with the top layer being flat cells. That's why it's called stratified, many layers. Squamous is a description of the top layer of the epithelium, how it looks like, what's the shape of the top layer of the epithelium is squamous, means flat. Oral epithelium in some regions is keratinized, in some regions is non-keratinized. Oral epithelium, most of the oral epithelium is ectodermally derived. Some of the regions in the most posterior part of the oral cavity might be endodermally derived. We have different layers of the oral epithelium according to their keratinocyte differentiation. So as we said, it's a stratified epithelium, means it has a number of layers. And each layer has a name. As you see in the figure, if we go closely, here we see this epithelium is keratinized. This epithelium is called parakeratinized, and this epithelium is called non-keratinized. You see the bottom layers, basal layer, then prickle layer. This is shared through all the types. So always we have the deepest layer as a basal layer, then we have prickle layer, and all of them. The names change in the last or the most superficial two layers. In the keratinized and parakeratinized, we have a granular layer, then keratin layer or keratinized layer. Some people call the top layer of orthokeratinized as orthokeratin layer. The top layer of the orthokeratinized epithelium as orthokeratin layer, top layer of parakeratinized epithelium as parakeratin layer. In the non-keratinized epithelium, as you see, we have the top two layers, intermediate, then superficial layer. You see here in the non-keratinized epithelium, the top layer is cellular. So we can identify living cells at the top. While in the orthokeratinized and the parakeratinized, we have a keratin layer. The most superficial layer is a keratin layer. It's a dead layer. It has no cells. They are dead cells filled with keratin. The orthokeratin, there are no remaining nuclei in the top layer. If there are nuclei, some nuclei, they are insignificant in number in the orthokeratin, like 1 or 2 cells in the section, 1 or 2 nuclei, in the section, retained nuclei. In the parakeratinized, There are a significant number of retained nuclei in the parakeratin layer, in the top keratinized layer. That's the basic difference between orthokeratinized epithelium and parakeratinized epithelium. The name of the layers in the keratinized epithelium, when we say keratinized, we are referring to both orthokeratinized and parakeratinized, and we explain the difference between orthokeratinized and parakeratinized epithelium. So keratinized epithelium, whether being orthokeratinized or parakeratinized, the naming of the layers is the same. Bottom layer, it's called basal layer, or also called stratum germinativum or stratum basale. Then we have, on top of it, so we are going from bottom up, from deepest to most superficial. Deepest, stratum germinativum, stratum basale or basal layer. Then we have stratum spinosum or prickle cell layer. Then we have stratum granulosum or granular layer. Then we have stratum corneum or keratinized or cornified layer. Now, as we explained before, some references call the keratinized layer as orthokeratinized or parakeratinized layer, depending on the type of epithelium, whether being ortho or parakeratinized. Non-keratinized epithelium layers: deepest layer, stratum germinativum, stratum basale, then or it's called basal layer, then stratum spinosum, prickle cell layer, then stratum intermedium, intermediate layer, then stratum superficiale or superficial layer. You see, the first two layers, or the deepest two layers, stratum germinativum, stratum spinosum, is the same, whether in keratinized or non-keratinized epithelium. The top two layers, the names are different. In case if you have keratinized, then you call them stratum granulosum, then stratum corneum. In non-keratinized, you call them stratum intermedium, then stratum superficiale. We come back again to the same figure as we explained before. This epithelium, this one here is orthokeratinized. You see, top layer is keratin, no retained nuclei. Here, this epithelium here is parakeratinized. Top layer is keratin, but we have a significant number of retained nuclei. This epithelium is non-keratinized. We don't have a keratin layer on top. We have cells on top, viable cells. Now we will explain the features of each layer, starting with the stratum germinativum. It's a single cell layer, and by the way, it's the only single cell layer. All the other layers have multiple rows of cells. Here we have only single row of cells, the most basal part of the epithelium. see here in this representation, this represents the cells of the basal layer. This represents the cells of the brachial layer. This represents the cells of the granular layer. And this represents the cells of the para-keratin layer, because we can see a retained nuclei here. There is no retained nuclei, then it's orthokeratin. So as you look here, cells of the basal layer are cuboidal. You can see it's cuboidal. This layer has high mitotic activity. The basal layer has high mitotic activity because it's the stem cell layer of the epithelium. That's why it's called stratum germinativum. Whenever it's anything called germinativum, means there is high mitotic activity. So it's a regenerative tissue. It's a regenerative. These are regenerative cells. They regenerate. Some of the cells here, of course, will be continuously lost due to function, of course, and they should be replaced. They should be replaced from the deeper layers. So if some parts of the keratin layer are lost, and they will be lost by function, they will be replaced by the cells of the granulosum. Then the cells of the granulosum will be replaced by the cells of the brachial layer. Then the cells of the brachial layer will be replaced by the cells of the basal layer. So there is, the basal layer is the regenerative layer of the epithelium. The cells of the stratum germinativum or the basal layer are separated from the lamina propria by basal lamina, because what's underneath this cell, basal layer, belong to the epithelial layer, and underneath we have lamina propria, epithelium and connective tissue. There should be between them basement membrane, which is also called basal lamina. In the electron microscopy, they call it basal lamina. In light microscopy, they call it basement membrane, but it's essentially the same thing. Cuboidal cells, progenitor cells of keratinocytes. When we say keratinocytes, we are referring to the epithelial cells. So the epithelial cells are also called keratinocytes. Why they call them keratinocytes? Because they have the potential to produce keratin. Even non-keratinized epithelium, they have the potential to produce keratin. When they are subject to friction, they will become able to produce keratin to protect themselves. So keratin is basically a protective layer. So in areas of the oral cavity where they are subject to high friction, we have the epithelium keratinized. In areas that are less subject to friction, we have the epithelium non-keratinized. Mitosis is confined to this layer. So the basal layer is where we find mitosis, cell division. Other layers we don't have cell division. We have maturation. In this layer, basal layer, cell division. Other layers, maturation. They mature, but they do not divide. So the basal layer is the least differentiated, and the keratin layer is the most differentiated, followed by granular, followed by brachial, And the least differentiated, as we said, is the basal layer. Any tissue that has mitosis is least differentiated. Daughter cells mature while ascending to other layers. So this cell in the basal layer, when it divides, it gives two cells. One remain as part of the basal layer and the other go up. This is called the daughter cell. The daughter cell will become part of the brachial layer. So it will change its shape from this cuboidal shape to polygonal shape and become similar to the cells of the brachial layer. And the top layer of the brachial layer, they will mature to look like the cells of the granular layer. They become flat and have all the features of the granular layer. Then the top part of the granular layer mature and become mature further and become part of the keratin layer. Some of them retain their nuclei in case of parakeratin, while in orthokeratin all of them lose their nuclei and become just sacs filled with keratin, which is the case in orthokeratin. We continue with this stratum germinativum, least differentiated as we explained. Stem cells are thought to be within the ridges that project into the underlying lamina propria. So here we're explaining for example here, they are called rate ridges. These projections, the projections toward the lamina propria, epithelial projections toward the lamina propria. These are called rate ridges or rate peaks. The deepest part of these rate ridges where we have the highest mitotic activity. Still we have mitotic activity throughout the basal layer, but the highest mitotic activity are in the depth of the ridges. That's what's meant by that sentence. Diurnal variation in the mitotic activity. So there is difference in the mitotic activity during the day. Negative feedback to inhibit further maturation. These cells, basal layer, they have a mechanism, negative feedback mechanism that maintain these cells in their immature status so that they can continue to divide and regenerate the epithelium. Now, second layer over the basal layer, we have stratum spinosum. The stratum spinosum have several layers, meaning several rows of cells. They are round to ovoid, the shape of them round to ovoid, and also sometimes polygonal, as you see here, polygonal cells. Larger and rounder than basal cells. Cytokeratin types that contribute to the formation of tonofilaments. So they contain cytokeratin types that contribute to the formation of tonofilaments. And tonofilaments as part of the structure of the cell and will be part of the keratin layer as well. Also in this layer, stratum spinosum, we identify the first appearance of involucrin, which is a protein involved in the formation of keratin. Stratum spinosum has decreased synthetic activity. Also, we identify in the stratum spinosum what's called oblong bodies. Oblong bodies are intracellular granules rich in phospholipids. These bodies have a role in the keratinization process. The stratum spinosum have lots of desmosomes. Desmosomes, they are a type of cell junction, mechanical junctions between the cells. We have numerous desmosomes in this layer. Other layers, they have desmosomes, but less. So the layer that has most desmosomes connecting the cells together within the epithelium is the stratum spinosum. And this numerosity of desmosomes led to the spiny appearance of these cells. When in section, when you prepare the tissue containing cells, epithelial cells, for sectioning, the tissue will experience a shrinkage. And imagine when you have a shrinkage of the cells and there are numerous desmosomes connecting the cells together. So that will lead to a spiny appearance of the cell. So the numerosity of these spines is due to the numerosity of desmosomes holding the cells together. In these pictures, slides, you see the black areas between the cells, black dots or black lines. These are desmosomes. They are numerous. Also here, numerous desmosomes. You see these black dots are the desmosomes. You see the cell here has round nucleus, has large cytoplasm, polygonal in general. These are characteristics of the prickle layer. Parabasal layers are the deepest layer of this layer. So, as we said, stratum spinosum has multiple rows of cells. The deepest of these rows, meaning close to the prickle layer, close to the basal layer, is called parabasal. Parabasal means very close to the basal layer, the part of the stratum spinosum that's very close to the basal layer. Then we have stratum granulosum. Stratum granulosum is present in keratinized epithelia, not in non-keratinized. Present in keratinized epithelia, whether being ortho or para-keratinized. You see, it's represented in the figure as flat cell. The cell is flat, the nucleus is flat, and in the cytoplasm of the cell we have granules. These granules are called keratohyalin granules. So these are the characteristics of the cells of the stratum granulosum, and it's usually 2 to 3 rows of cells. 2 to 3 rows of cells. It's not just a single row of cells. The stratum spinosum has reduced organelles, larger and flatter cells, large number of keratohyalin granules. These granules contain the precursor to filaggrin, which is an important protein to the formation of the keratin layer. Top layer of the keratinized epithelium, stratum corneum, loss of all organelles. So the cell become dead and lose all its organelles. The cell become filled with tonofilaments surrounded by filaggrin. So tonofilaments and filaggrin are very essential part of the keratin. So this is what make the keratin layer. The keratin layer is basically dead cells that lost all their organelles and now they are filled with just tonofilaments surrounded by filaggrin. The desmosomes between the cells are weakened. They are not lost completely, but they are weakened. In nuclei, most of the nuclei are lost. Some nuclei might be retained. If they are retained in a significant number, then the epithelium is called parakeratinized. If the nuclei are completely lost in this layer, then it's called orthokeratin. If there are a few, 1 or 2 nuclei left, these are insignificant number and we still call it orthokeratin. These nuclei, when they are retained, they are called pycnotic nuclei. Pycnotic nuclei. Pycnotic means it's shrunken and deeply stained. Shrunken, deeply stained nuclei. This is what's meant by pycnotic nuclei. And this refers to the retained nuclei in the keratin layer in case of parakeratinized epithelium. Epithelial squamous desquamation. So because the desmosomes are weakened, so these sacs of keratin, the dead cells, can be easily lost during function. These lost dead cells are called epithelial squames, and the process is called desquamation. Stratum corneum, the normal thickness of keratin layer is about 2 to 3 cells. This is the normal. Here it's written thickness up to 20 cells. Up to means in abnormal cases, when there is high friction. For example, cheek biting. When you bite on your cheek by your teeth, this is a friction, and the cells of the cheek, the epithelial cells of the cheek, buccal epithelium, respond by producing keratin, and it will make a thick layer of keratin as a protective layer. So this is induced. When they make 20 layers of cells more than 2 to 3 layers of cells, then this is induced. This is not the normal situation. The normal situation, there's like no external factors that induce the production of extra keratin. Then it's normally 2 to 3 layers of cells. But when it's induced, it could reach up to 20 layers of cells. That's what meant by it. So you see here, this layer, all this layer is a parakeratin layer. It's a thick keratin with lots of retained nuclei. That's not normal. This is induced keratinization. So we call this layer granular layer. So this layer is called parakeratin layer. Then we call this granular layer. Then we call this prickle layer. Prickle layer, you see when the nuclei become round, you call it prickle. When the nuclei are flatter, you call it granular. Parakeratinized epithelium has pycnotic nuclei in the stratum corneum, and we explained that pycnotic nuclei means retained nuclei, deeply stained, shrunken nuclei. Orthokeratin is the case where there are no or insignificant number. Non-keratinized epithelium. Non-keratinized is also called lining epithelium. It has less developed tonofilaments. It lacks keratohyalin granules. But in keratinized, we find keratohyalin granules in the granular layer. Here we don't have a granular layer. We have intermediate layer in place of a granular layer. And instead of the top keratin layer, we have a stratum superficiale. So the naming of the layers from bottom up, have here basal layer, then prickle layer. First two layers same. Then we have intermediate layer, then we have superficial layer. You see the intermediate layer and superficial layer, both flat cells with flat nuclei. But here you see the nucleus is smaller. In the superficial layer, the nucleus is smaller than the nucleus of the intermediate layer. But sometimes in real sections you can't really tell there is a difference in size, in the size of the nucleus. So we consider the first 2 to 3 rows of flat cells as superficial, 2 to 3 rows of flat cells as superficial, and then 2 to 3 rows of flat cells, or the remainder of flat cells, as intermediate layer. Then when the nuclei become round, then we are in the prickle layer. And the deepest part, the deepest row, is called basal layer. It's a single row of cells. Cytokeratins are a class of intermediate filaments specific to epithelial cells. We have 20 cytokeratin types, cytokeratin 1 to 20. They are products of 2 gene families. So the cytokeratins, it's like self-study. So they are not included in the examination. So if you want just to read them for your knowledge, so it's self-reading. Oral epithelium phenotype. The type of epithelium could be determined by external stimuli, especially from the underlying lamina propria, epithelium-mesenchymal interaction, innate properties within the epithelial basal layer. So this is about what decides that the epithelium is keratinized or non-keratinized. What decides? Is it the lamina propria beneath, or it's something inherent to the epithelium itself to be keratinized or non-keratinized? Now we will come to subject about non-keratinocytes. Non-keratinocytes, they are present in both keratinized or non-keratinized epithelium. Non-keratinocytes, as we explained before, keratinocytes are the epithelial cells. Epithelial cells are called keratinocytes. So, non-keratinocytes are cells that are present within the oral epithelium, also present within the epidermis of the skin, but they are not epithelial cells. They have different origin, so they are foreign cells. They have different origin from the oral epithelial cells. Originally, these cells were called clear cells. Keratinocytes or epithelial cells stain positive with the eosinophil stain. Non-keratinocytes, they stain negative. The cytoplasm stain negative. The nucleus always stain, always take up the eosinophil stain and appear like dark blue. But the cytoplasm of these cells, non-keratinocytes, they do not stain positive. That's why they were originally called clear cells. Then when they identify these types, these cells, they discover that they are different types. They are not the same. They include melanocytes, Langerhans cells, Merkel cells, and inflammatory cells. That's in case of inflammation. But in case under normal circumstances, we have just the three types: melanocytes, Langerhans cells, and Merkel cells. They constitute 10% of the oral epithelial cells. 10% of oral epithelial cells are non-keratinocytes. So their percentage of the oral epithelium is 10%. That's in normal circumstances. But in case of inflammation, this will be increased more than 10%. So in normal circumstances, melanocytes, Langerhans cells, Merkel cells make up 10%. In case of inflammation, you add inflammatory cells, which migrate through the epithelium. In case of inflammation, this will increase the percentage. These cells lack cytokeratins and appear as clear cells in eosinophil stain sections because they lack cytokeratins. Keratinocytes, they have cytokeratin. That's why they stain positive for eosinophil stain. See in this section. By the way, this section is orthokeratinized. See here, this top layer here is keratin, dead layer. We have here two retained nuclei, but they are not significant to call it parakeratin. If we have many of these, significant number of these retained nuclei, then it's parakeratin epithelium. But in this case, they have only two retained nuclei in the keratin layer. Then this is still orthokeratin. Then we have granular layer, which is normally 2 to 3 layers of flat cells. Then we have Purkinje layer. See, the nuclei are round. You go all down, still Purkinje. Only the basal layer. Only the basal row of cells is called basal layer. The remainder up to the granular layer is called Purkinje layer. So Purkinje layer is the largest layer. Now the topic is about the non-keratinocytes. Means there are some cells within the epithelium, their cytoplasm is clear, like this cell, this cell, this cell, this cell, this cell. Any cell within the oral epithelium that doesn't take up the stain, the cytoplasm appear clear, you identify the nucleus. The nucleus is there, you can identify it, but the cytoplasm is not stained. So when you see a cell with the cytoplasm not stained, then it means that this cell is non-keratinocyte. It could be a melanocyte, Merkel cell, or Langerhans cell. Now we'll talk about the different types of non-keratinocytes. The first type is melanocytes. Melanocytes are melanin-producing cells situated within the basal cell layer. They are derived from the neural crest cells, neural crest derivatives. So where they are derived from, melanocytes, they are derived from the neural crest. They have long processes. So this cell is considered a dendritic cell. Dendritic cell, it has dendrites. Melanin is produced using tyrosinase. So these cells, melanocytes, produce melanin using an enzyme called tyrosinase. They contain protein synthesizing organelles. Within the melanocytes, you can identify protein synthesizing organelles. And as you know, protein synthesizing organelles include rough endoplasmic reticulum and Golgi apparatus. Golgi apparatus for post-translational modifications. And these cells contain melanosomes. Melanosomes are like vesicles containing melanin. They are numerous within these cells. First, we look at the corner of the figure. This is light microscope image. You see a large cell, multidendritic, has multiple dendrites, located within the basal layer. This is the basal layer of the epithelium. It's located within this layer. And this is a special stain for melanocytes. So the cell that's highlighted here is a melanocyte because they used a special stain to highlight melanocytes. Because normal eosinhematoxylin stain will not highlight. Normal eosinhematoxylin stain will not highlight melanocytes. It will appear as a clear cell, just a clear cell. but a specialist here will highlight it. Here we see electron microscope image of a melanocyte. So you see the nucleus flat. You see it has numerous melanosomes, vesicles filled with melanin. Each melanocyte can contact up to 40 keratinocytes. Keratinocytes here, we are talking about oral epithelial cells. Keratinocytes release mediators important for melanocyte function. So the keratinocytes, they control the function of melanocytes. Keratinocytes take up melanin by actively phagocytosing the melanocyte's dendritic tip. So melanocytes, they have multiple dendrites. The tips of the dendrites touch keratinocytes, up to 40. Then the keratinocytes phagocytose the tips of the tips of the dendrites of melanocytes. These tips contain what? Melanosomes. Melanosomes contain melanin. So the keratinocytes want the melanin. For what? For protection. Protection against mitosis. Protection against to protect themselves from mutations during mitosis. That's why melanocytes are present within the basal layer, or sometimes in some references they are within the basal or just above the basal layer. In either case, they contact the cells, mainly the cells of the basal layer. And the cells of the basal layer, they undergo continuous mitosis because they are the stem cells of the epithelium. They need the protection most from UV light or any other mutagenic substances or rays. That's why they need the melanin so much, to protect the dividing cells, the mitotic cells, from developing mutations due to external factors such as UV light, for example, ultraviolet light. The degree of pigmentation is affected by, here, as you know, some people light skinned, some people dark skinned, and some in between. So what mainly decide whether having dark skin or light skin is mainly the degree of pigmentation, the degree of melanin pigmentation. And this is affected by a number of factors: the size and the degree of branching of melanocytes, rather than the number of cells. So the number of cells is the same, whether in a dark-skinned person or a light-skinned person. The difference is in the other things, other than the number. First factor, size and degree of branching of melanocytes. Second factor, size of melanosomes. Third factor, the number and degree of dispersion of melanosomes. Fourth factor, the degree of melanization of melanosomes. Fifth factor, degradation rate of the pigment. Here we are looking at the oral cavity, gingiva, the gingiva here, gum of a dark-skinned person. In dark-skinned people, there is a high likelihood to have darker spots, areas of darker pigmentation than the surrounding areas. Spots, dark spots on the gingiva. These are called racial pigmentation. And under the microscope, you see melanin pigment in the lamina propria. This is the epithelium. This is lamina propria. The melanin should be contained within the epithelium in normal cases. When it goes down, it cannot be degraded. So they pool and make like a cluster of pigment underneath the epithelium, which explain the dark spots in case of melanin of racial pigmentation. Under the microscope, they call it melanin. In histology, they call it melanin incontinence. In clinical cases, they call it racial pigmentation. It's the same, just different naming. Keratinocytes, epithelial cells, have the ability to degrade melanin, but the connective tissue doesn't have the ability to degrade melanin. That's why when the melanin goes down to the connective tissue, it will not be degraded. Smoking increases the likelihood of racial pigmentation. These spots, dark spots, so they increase by smoking. We don't need to do management or treatment for racial pigmentation. Just we reassure the person that this is it's not harmful and doesn't need any treatment, and when they quit smoking they will go away gradually, slowly, because as you see it's in the connective tissue. It's not easy to get rid of in the connective tissue, but eventually they will be get rid of course, but it will take longer time. Second type of cells, Langerhans cells. They are dendritic cells. Melanocytes are dendritic, Langerhans are dendritic. Both are clear cells, but they have differences in function. Antigen presenting cell. Here Langerhans are antigen presenting cells, while melanocytes, they produce melanin. The location is different as well. The Langerhans cells are located above the basal cell layer, while melanocytes located within the basal layer or just above the basal layer. Also, the origin is different. Melanocytes derived from neural crest cells, while Langerhans cells are derivatives of bone marrow precursors. They leave the bloodstream and enter the lamina propria before penetrating the stratum germinativum. So their origin is from the bone marrow. Chemokines secreted by keratinocytes act as chemotactic factors. So we need chemotactic factors from the oral epithelial cells to attract these cells from the lamina propria to go inside the epithelium. This is light and electron microscope image. Here, light microscope image. This is electron microscope image. In the light microscope image, you see this cell. Of course, we are using a special stain to highlight Langerhans cells. You see it as a multi-dendritic cell, large cell within the Purkinje layer. You see here the nuclei are round. You can identify them. Round nuclei. Round nuclei is characteristics of the Purkinje layer. So this cell is large dendritic cell within the Purkinje layer. It's Langerhans cell. This is electron microscope image of Langerhans cell. A Langerhans cell. You see it has a large nucleus. It has multiple indentations, invaginations. The arrowheads here are pointing at rod-like structures. These rod-like structures are called Berbick granules, and they are thought to have a role in antigen presentation, which is the function of this cell. Langerhans cells, they move to local lymph nodes via dermal lymphatics. Because they are antigen presenting cells, they want to present antigen. They interact with foreign antigen, whether it's from a bacteria or a virus or whatever foreign material. When they interact with it, they want to present it. Where they go to present it? They should present it to T lymphocytes. And T lymphocytes, they are present in the lamina propria, of course, and also present in the lymph nodes. So they go to the lymph nodes. Not all of them, some of them go to the lymph nodes to present the antigen to the T lymphocytes. So, and then the T lymphocytes will take it from there to continue the immune reaction against the foreign antigen. ATPase is on the cell membrane of this cell. Berbick granules, as we explained, these where we see the arrowheads, these structures, rod-like structures, are present within these cells. These cells interact with T lymphocytes. When they bind with foreign antigen, they interact with T lymphocytes, whether in the lamina propria or in the regional lymph nodes or both. Functions of Langerhans cells. They play an important role in contact hypersensitivity reaction of the skin. Here they are talking about Langerhans cells of the skin. They have a role in anti-tumor immunity because tumor cells are considered as foreign cells, and the proteins expressed on the surface of tumor cells are identified as antigen, foreign antigen for Langerhans cells. They also have a role in graft rejection. Grafts also are considered as foreign body, foreign antigen for these cells, Langerhans cells, so they tend to reject grafts. They react as a propagator of HIV-1 transmission to T cells. HIV-1, which is also called the AIDS virus, a human immune deficiency virus type 1. These cells interact with HIV-1 and present the virus to the T lymphocytes. It's doing its job. Present it to the T lymphocyte. But this virus go inside T lymphocyte and replicate within T lymphocytes. So they propagate the HIV-1 unintentionally. They want to present it to the T lymphocyte. It doesn't want to infect T lymphocyte with the virus. Third type of non-keratinocytes is called Merkel cells. But this one only present in keratinized epithelia. Not all oral epithelia have Merkel cells. But all oral epithelia have melanocytes and Langerhans cells. Merkel cells only present in keratinized epithelia that are subject to masticatory loads. We have two types of epithelia. They are called masticatory epithelia. Masticatory epithelia present in the gingiva and the mucosa covering the hard palate. Hard palate is the roof of the mouth that is supported by bone. It's called hard palate. The mucosa covering it is keratinized. The gingiva is keratinized. Both are classified as masticatory mucosae or masticatory epithelia. Then in this epithelium we have Merkel cells. Other epithelia in the oral cavity do not have Merkel cells. Found in the basal layer, but they are not multidendritic. So different from melanocytes, they are not multidendritic. The similarity, they have the same location. They are found both in the basal layer. Also another similarity is their origin. Both derived from neural crest cells. Found in the basal cell layer, close to nerve fibers, act as a receptor. They are neural crest derivatives. They contain cytokeratin 8 and 18 or cytokeratin 8 and 20. So it's always have cytokeratin 8 coupled with 18 or coupled with 20, because the cytokeratins come in pairs. A pair 8 with 18 and 8 with 20. Come in masticatory mucosa, absent in lining mucosa. Lining mucosa are non-keratinized mucosa, so you cannot find it in non-keratinized epithelia. We only find it in masticatory epithelia, keratinized epithelia. So if we ask you, like a clear cell found in the basal layer of non-keratinized epithelium, should be melanocyte. Clear cell found in the basal layer of keratinized epithelium, it could be Merkel or melanocyte. If I add that it's dendritic, then it's melanocyte. If I add it's non-dendritic, it's a Merkel cell. In the clear cell in the basal layer of keratinized or non-keratinized epithelium always is Langerhans cell. This is electron microscopy image of a Merkel cell. You see, the cell has large nucleus. It has multiple deep indentations, deep invaginations. They have a particular structure here within the nucleus. It's like a nucleolus, but has special shape. They call it a nuclear rodlet. Nuclear rodlet. In the cytoplasm, it has numerous vesicles, tiny vesicles, numerous tiny vesicles, small vesicles. And these vesicles contain neurotransmitters. When this cell is subject to pressure, They are mechanical receptors. They sense pressure. That's why they are present in masticatory mucosa. Masticatory mucosa are the mucosa that's most subject to pressure of mastication. You see here, they are closely associated with an axon, nerve axon. So they should be present within the basal layer, because nerve axons are in the lamina propria. We know that oral epithelia are not innervated. Nerve fibers cannot reach epithelia. Blood vessels cannot reach epithelia. So epithelia are never penetrated by blood vessels or nerve fibers. So the nerve axon should be in the superficial part of the lamina propria, and the Merkel cell should be in the deepest part, which is the basal layer of the epithelium. When it's subject to pressure, they release neurotransmitters and excite the nerve axon. The action potential takes place within the axon, and the message is sent to the central nervous system. Merkel cells they have deeply invaginated nucleus. They contain nuclear rodlet. They have mitochondria, free ribosomes and granules, vesicles adjacent to nerve. Vesicles, here we are talking about vesicles containing neurotransmitters. Lamina propria have two main parts. We have superficial papillary and deep reticular layer. This epithelium here is keratinized epithelium. You see keratin layer. You see the interface between the epithelium and the underlying connective tissue is not straight line. It's like there is interdigitating ridges of epithelium and papillae of the connective tissue. These are called, the epithelial projections are called rate ridges. The connective tissue projections are called connective tissue papillae. So the connective tissue papillae together, they are called papillary layer, superficial papillary layer of the lamina propria, and it's a loose connective tissue, has loose thin collagen fibers, while the second part of the lamina propria is called deep reticular layer, and it has a thick parallel collagen bundles. Thick collagen bundles running in this direction. Collagen fibers in the papillary layer, they run in this direction at right angle to the surface of the epithelium. So we have two main parts: superficial papillary layer, loose thin collagen fibers; deep reticular layer, thick parallel collagen bundles. Lamina propria has, it's like any connective tissue, has fibroblasts, immune cells, including histiocytes, mast cells and lymphocytes. They have extracellular matrix. Collagen is the main protein in the extracellular matrix of the lamina propria and any connective tissue. 90% of collagen is type 1, 8% type 3. So the most abundant type is collagen type 1, then type 3. The other types are come in very small amounts. Small amounts of non-fibrillar collagen, elastin, oxytolin, proteoglycans, and glycoproteins. All of these present in the extracellular matrix of the lamina propria. Epithelial connective tissue interface. Epithelial connective tissue interface is the junction between the epithelium and the underlying connective tissue, which is the lamina propria in case of the oral cavity. This interface or junction is called basal lamina or basement membrane. Basal lamina in the electron microscope they call it basal lamina. In light microscope images they call it basement membrane, but they are the same thing. It's composed of thin fibrils and ground substance. It has two zones. First zone, lamina lucida, 20 to 40 nanometer thick, immediately under the epithelium. So just below the epithelium, which is the basal layer of the basal layer of the epithelium, we have lamina lucida, 20 to 40 nanometer thick. Then we have lamina densa, 20 to 120 nanometer thick. It's thicker. The densa is thicker than the lucida. Then we have fibroreticular lamina. Some references consider it as a third layer, and some references consider it as part of the lamina densa. We'll explain that more. Here in this image, see here we see lamina lucida. It's light, that's why it's called lucida. These are called hemidesmosomes. Hemidesmosomes, the half desmosomes. They are attaching the cells of the basal layer to the basement membrane. Lucida, light zone. Then densa, dark zone. Lamina lucida, lamina densa. Then we have these anchoring fibrils, arc-shaped fibrils. Arc-shaped fibrils are called the fibroreticular layer. You see in this drawing, it represents the same thing. Basal cells, hemidesmosomes interacting with ionofilaments, lamina lucida, lamina densa, anchoring fibrils, arc-shaped fibrils. And we have collagen fibers interacting with these anchoring fibrils. So now we come to the chemical composition. In the lamina lucida, the main protein is laminin. It interacts with the hemidesmosomes. It's attached to the hemidesmosomes. Then the laminin of the lamina lucida interacts with collagen type 4, which is the main protein in the lamina densa. So laminin in the lucida interact with collagen type 4 in the densa, and the collagen type 4 in the densa interact with the collagen type 7, which makes up the anchoring fibrils. So that's why they are connected together. Any problem in any of these important proteins, laminin, collagen type 4, collagen type 7, this will lead to splitting of the epithelium from the underlying connective tissue. And formation of vesicles. and some diseases are called vesiculobullous diseases. These diseases where the skin and oral cavity have vesicles, these vesicles then rupture, leaving ulcers. So these there where we have a defect in the basement membrane, one of the main proteins of the basement membrane. Epithelial connective tissue interface. Most components of the basal lamina are synthesized by epithelial cells. Lamina lucida is made of laminin, which is a glycoprotein. Laminin cements collagen type 4 collagen between lamina densa and the epithelial cells. Lamina densa is made of collagen type 4 coated with heparan sulfate. Thick collagen fibers attach to lamina densa to link the basal lamina to the connective tissue. We continue. Epithelial connective tissue interface. Fibronectin is sometimes found in the lamina densa and may bind fibroblast and proteoglycans to it. The role of the basal lamina provides mechanical adhesion between the epithelium and the connective tissue. It acts as a molecular barrier and has a role in response to injury. Oral submucosa. The submucosa is a layer of loose, fatty, or glandular connective tissue. As we mentioned before, this is the submucosa, sometimes present, sometimes absent. It's between, when it's present, it's between the lamina propria and the underlying muscle or bone. Okay. It can be glandular or fatty. It may contain salivary glands, it may contain fat, depending on the region. This layer contains major blood vessels and nerve supplying the mucosa and separating it from the underlying bone or muscle. So you see the large blood vessels and nerve bundles within this submucosa. Submucosa. The composition of the submucosa determines the flexibility of the mucosal attachment to the underlying structure. Minor, so when we have in a region in the oral cavity, when we have submucosa, then means the tissue is flexible, can be moved against the underlying bone or muscle. But when we don't have submucosa, then we have the tissue firmly attached to the underlying bone or muscle. Minor salivary glands of both mucus and serous types and rarely sebaceous glands can be present. So in the submucosa, sometimes we have fat tissue, sometimes we have glands, minor salivary glands, whether being mucus or serous or mixed. Nodules of lymphoid tissues can be also seen. Also in the submucosa, in some region of the oral cavity, like the lingual tonsil area, on the posterior 1/3 of the dorsum of the tongue, we have lymphoid tissue. So submucosa has differences in different regions. Regional variation depending on its function. The oral mucosa differ regionally in epithelial thickness. So from one part of the oral cavity to from one to another part of the oral cavity, there are differences in many different things. These include thickness of the epithelium, the keratinization, whether being keratinized or non-keratinized, being ortho or parakeratinized, complexity of the epithelial connective tissue interface, the interdigitating rete ridges of the epithelium and the connective tissue papillae. They have different complexities in different regions. Sometimes it's like more linear, sometimes it's like more complex. Composition of the lamina propria, presence or absence of submucosa, and the nature of the submucosa if it's present, whether it's fatty or glandular or lymphoid or regular submucosa. Oral mucosa types. Types of oral mucosa. Oral mucosa types, depending on the location and function of the epithelium, the oral mucosa are classified into masticatory oral mucosa, lining oral mucosa, specialized oral mucosa. Masticatory oral mucosa in two parts of the oral cavity, gingiva and the mucosa overlying, the mucosa covering a hard palate, which is the roof of the oral cavity supported by bone. Specialized mucosa, we have four parts of the oral cavity that are considered specialized mucosa. Anterior 2/3 of the tongue dorsum. Tongue dorsum is the rough part of the tongue, the upper part of the tongue. Ventrum is the below part of the tongue. Also lingual tonsil area. Lingual tonsil area, which is located in the posterior 1/3 of the tongue dorsum. So we have two specialized mucosa related to the tongue. The anterior 2/3 of the tongue dorsum and the lingual tonsil area, which is in the posterior 1/3 of the tongue dorsum. The third specialized mucosa is the vermilion zone of the lip, what we call lip or red zone of the lip is called in histology vermilion zone of the lip. Also, we have junctional epithelium as specialized mucosa. Junctional epithelium is the epithelium that binds part of the gingiva to the enamel of the tooth. This is called junctional epithelium, and this is specialized mucosa. The remainder of mucosa in the oral cavity, if it's not part of masticatory or specialized, then it's a lining mucosa. You only need to remember masticatory and specialized, and then the rest is lining. Lining always non-keratinized, masticatory always keratinized. Specialized, we have 2 keratinized and 2 non-keratinized. The anterior 2/3 of tongue dorsum is keratinized. Vermilion zone of the lip keratinized. Lingual tonsil area of the posterior 1/3 of tongue dorsum non-keratinized. Junctional epithelium or attachment epithelium, also called, is non-keratinized. Masticatory oral mucosa, area subjected to high compression and friction, covers part of the hard palate and the gingiva. Epithelium is keratinized and the lamina propria is thick. Lining mucosa, not subject to high levels of friction, mobile and distensible, covers lip, cheeks, alveolar mucosa, soft palate, ventral surface of the tongue, floor of the mouth. Epithelium non-keratinized, lamina propria is loose. Specialized oral mucosa includes dorsal surface of the tongue, namely anterior 2/3 of the dorsum of the tongue. Lingual tonsil area, which are located on the posterior 1/3 tongue dorsum. Gingival attachment to teeth. This is the junctional epithelium that attach part of the gingiva to the enamel of the tooth. Vermilion zone or vermilion border is the red zone of the lip. Here we are looking at the lip histologically. So the lip histologically has 3 parts. The vermilion zone of the lip is what we call lip, but in histology it's called vermilion zone of the lip. We have oral side of the lip, and we have a skin side of the lip. Skin side of the lip, which is like any skin, normal skin. This is oral side of the lip, which is non-keratinized epithelium. You have lamina propria, you have submucosa, containing minor salivary glands, mixed type. We have muscle here, core muscle. It's called auricularis oris. The oral side of the lip, the mucosa is classified as lining mucosa. It's non-keratinized epithelium. Vermilion zone is classified as specialized. Skin side of the lip is skin, so it's keratinized. Vermilion zone is specialized and keratinized. It's keratinized, but doesn't have skin appendages like hair follicles and sweat glands. Skin side of the lip, it's like any skin. It has skin appendages including hair follicles and sweat glands. At this magnification we can identify hair follicles, but it's difficult to identify sweat glands. Here in the vermilion zone, we don't have hair follicles or sweaty glands. The skin on the outer surface and labial mucosa on the inner surface. Skin on the outer surface of the lip and labial mucosa on the inner side. Vermilion zone in between, also called transition or red zone. Striated muscle of facial expression in the lip core. So in the core of the lip we have a muscle, skeletal muscle, striated muscle. It's called orbicularis oris. Minor salivary glands in the submucosa. So here in the oral side of the lip, as we said, you have non-keratinized epithelium, lamina propria, then submucosa containing minor salivary glands, mixed type. Then we have here the core muscle, which is orbicularis oris. From the skin side, you will have epidermis, thin keratinized epithelium with skin appendages, hair follicles, sweat glands, and sebaceous glands. You have thick dermis, then you have thick hypodermis. Dermis is thick connective tissue, dense connective tissue. Hypodermis is light or loose connective tissue, and then you have the muscle, core muscle. In the skin you have epidermis, dermis, and hypodermis. Oral side of the lip you have oral epithelium, you can call it labial epithelium, then lamina propria, then submucosa, then the muscle. Vermilion zone, you have epithelium keratinized, but without skin appendages, without hair follicles, sweat glands. Then you have lamina propria, then you have muscle. No submucosa, no hypodermis in the vermilion zone. Here we are looking at the lip. A is the skin side of the lip. Skin side of the lip. You see here keratin, you see hair follicles and shafts, skin appendages. See oral side of the lip. You see thick epithelium compared to the thin epithelium of the skin. Oral side of the lip. B, vermilion zone. It's thin like the skin side of the lip, but no skin appendages, no hair, basically. This is the vermilion zone of the lip. Skin side of the lip A. C, oral side of the lip. D is minor salivary glands, mixed minor salivary glands in the submucosa of the oral side of the lip. As you have epithelium here, then lamina propria about the same thickness. Oral epithelium and underlying lamina propria, they are about the same thickness. And you have submucosa with these structures. And these are minor salivary glands, mixed type. The lip skin. The skin of the lip has a keratinized epidermis, connective tissue dermis, hair follicles, sebaceous glands, sweat glands. See here, epithelium thin keratinized, then we have dense connective tissue dermis, thick dermis, loose connective tissue which is hypodermis. Now the structures. A is a sweat gland. It's tortuous gland. It has wavy course. That's why you see it in bits and pieces, in sections. C is a hair shaft. This is hair follicle, oval. So the hair has oval part, hair follicle, and straight part, hair shaft. This is sebaceous gland, associated with hair shafts and follicles for lubrication of hair. This is again skin side of the lip, thin keratinized epithelium, hair shaft, associated with sebaceous glands, hair follicle, associated with sebaceous gland, vermilion zone, no skin appendages, no hair, no sweat glands. Occasionally you can find sebaceous glands, especially around the corners in the area of the corners of the lip. But these sebaceous glands are called ectopic sebaceous glands because we don't have hair here. Normally sebaceous glands should be associated with hair, but if you don't have hair, then the sebaceous glands are ectopic. That's why they are called Fordyce spots or Fordyce granules. Fordyce spots or Fordyce granules, which are ectopic sebaceous glands. No mucous glands because we don't have submucosa here. In the vermilion zone, you have epithelium, keratinized, and lamina propria, then muscle, no submucosa, then no mucous glands, no salivary glands. Keratinized, thin, translucent epithelium, so the epithelium is keratinized, thin, and translucent. Lamina propria has capillary loops, highly vascularized lamina propria. That's why the lip appear more reddish than the skin, because the epithelium is thin and translucent, and the underlying lamina propria is highly vascularized and has capillary loops close to the surface. Here A is about the vermilion zone. A is the vermilion zone. Notice the epithelium is thin, no hair follicles, no skin appendages. B, thick epithelium, non-keratinized, so it's oral side of the lip. C is a muscle, it's muscle tissue, so muscle in the lip should be orbicularis oris. Vermilion zone, the junctional region between vermilion zone and the labial mucosa is known as intermediate zone. It's a very thin zone in adults. It's the junction between vermilion zone and the oral side of the lip. This one is zone is significant in infants because it becomes thickened and form the suckling pad. This zone is parakeratinized zone. Labial mucosa, oral side of the lip, thick non-keratinized epithelium, wide lamina propria with short and irregular papillae, submucosa with many minor salivary glands, and these minor salivary glands are mixed minor salivary glands, mixed but mainly mucus. They have some serous, but they are mainly mucus. Dense connective tissue fibers bind the mucosa to the orbicularis oris muscle. Here you see labial mucosa, oral side of the lip. This epithelium thick non-keratinized epithelium. Then we have lamina propria, about the same thickness of the epithelium. Then we have submucosa, and in the submucosa you see this structure. This is minor salivary glands, mixed minor salivary gland. Then you have this tissue which is muscle, orbicularis oris muscle. The same arrangement is present in the buccal mucosa. Buccal mucosa, or the oral side of the cheek, has the same arrangement. You see non-keratinized epithelium, lamina propria, submucosa containing minor salivary glands, mixed type as well, and then muscle. But the name of the muscle is different. In the cheek, it's called buccinator. In the lip, it's called orbicularis oris. The cheek buccal mucosa, it's also lining mucosa, non-keratinized epithelium. Always when we say lining mucosa, it means non-keratinized epithelium. It has dense lamina propria, submucosa with many minor salivary glands, mixed mainly mucus like the lip, buccinator muscle beneath the glands, beneath the submucosa. This epithelium, part of the epithelium of the cheek, it looks like any non-keratinized epithelium. It looks like any lining epithelium. See here oral cavity. A here is the basal layer, B prickle layer, and it continues until the cells become flat. They become flat, like starting from here up to here will be the superficial, intermediate and superficial. First 2 to 3 layers is the superficial. Then the remainder of the flat cells is the intermediate layer. So up until here, B prickle layer, then we have intermediate layer, then the top 2 to 3 rows of cells is the superficial layer. Linea albobacalis means white line in the cheek in case of cheek biting. Look, this line corresponds to the area where the teeth come in contact with each other while chewing. So if there is some faulty occlusion in the teeth, there will be a tendency for cheek biting. And the oral side of the cheek is non-keratinized. Epithelium is non-keratinized, but when it's subject to the friction of cheek biting, it starts to form keratin, which appears like a white line. That's why linea albobacalis is a keratinized line in the buccal mucosa along the occlusal plane. When the problem is solved and the person stops biting his cheek, this will go away by itself. Doesn't need any management. We need to correct the occlusion of teeth. We don't need to do anything for the linea albobacalis itself. Ectopic sebaceous glands. Here in this photo you see yellow, a cluster of yellowish small structures. These are ectopic sebaceous glands. This oral side of the cheek, labial mucosa, and we see here ectopic sebaceous glands. We don't have hair here, so they are ectopic. They are sebaceous glands in the wrong place. Sebaceous glands should be in the skin where we have hair to provide lubrication.